Hello, hello everyone. This is another example for the probability of mutually exclusive events. Okay, so this example, if you observe it, you will feel this is similar to what we learned just we finished a week ago, right? Before the final. You see, this one is like a joy with a statistic, remember? And this, I think this example even much easier than what we learned before. But anyway, I bring it up to let you see what the probability is related to the statistic can do at the same time. And I think it's a good for SAT exam also. Okay, so now we take a look at this example. The personnel department of a company has compiled data on the numbers of employees who have been with the company for various periods of time. The results are shown in the table. That means this one, the green table here. If an employee, okay, this one separate to be two words. If an employee is chosen at random, what is the probability that the employee has A? Now question want us to find. Question A, 4 or fewer years of service. Second one, B, 9 or fewer years of service. This one really easy, right? I think everyone know how to get the answer right away, correct? But now they ask, the question asks us about the probability, okay? So it's not hard, right? We just see the table here, the green table here, year of service, right? This one, years of service. This one should have S. Year of service and the number of employees. So year of service, this one, they have, you can see the interval is what, 0 to 4 and 5 to 9 and so on, 10 to 14. So we can see the interval is what, is equal to 5, correct? You can get from 5 minus, this one is class minus, okay, 0 to 4 is a 5, or you can get 9 minus 4 here, either one. Like a statistic exactly, the statistic we just finished. But in statistics, we do have a question as for the probability also. But now this question is only probability alone. But then you can see how it's related. So we come back to here. Number of employees. So this one like a frequency, correct, in the statistics. So we name as a F, or just say frequency, right? This is a frequency. So you can see from the years of service, they have like each class is what, like a 0 to 4 have 157, and from 5 to 9 is 88, 89, and 10 to 14 is 74. First of all, you have to sum up the number of employees, right? Total up. So you just use 157 plus 89 plus 74 plus 63 plus 42 plus 38 plus 37 and plus 21. And this one going to be summation of F, or summation of S equal to, sum it up. So we have 5 to 1. You use calculator, okay, sum to F. So sigma F is the sum of numbers of the employees, the total of employees during from the 0 year up to 39 years of service. Okay, so now once you sum it up here, we can go back to get the question A now, right? 4 or fewer years of service. 4 or fewer, where they drop in here, right? This one, 0 to 4. 4 or fewer, or that means 4 or less, right? The fewer years of less than the year of service. So we have this one, 157 for question 4. Okay, so we have this one, 157 employees, this one 4 or fewer years of service. But the question want us to find probability. You just use the formula, right? P of event, right? The formula what we learned before, PE equal to NE, right? Over NS, the formula we learned before, okay? PE, the probability of errors, because the property like a question A, we have to find P of 4 or fewer years of service. NE is the number of outcomes, the number of outcomes in events, right? In E. Okay, so we represent this in NE. And in this, NS is what? NS is the number of outcome in the sample space, correct? Or can say the total, in this case is what? Number of employees, find the total of employees. So now for this case, you see, so we write down here. So we can write it down, maybe I do this way. So we write down P probability of 4 or fewer years of service. Okay. We equal to NE, that means NE, we only got it, this one, because the 4 or fewer looked up in here. So we're gonna have 157 divided by probability. That means sigma F is a 521. Okay, and then that's the answer for question A. Okay, then we come back to this one, question B. Question B do the same thing, right? Question B, we can do the same thing. Okay, so 9 or fewer, so use the same formula, correct? So then this one gonna be 9 or fewer years of service, so drop in where? 5 to 9, right? Right, so become 89. So we have this one gonna be P of 9 or fewer years of service. This one gonna equal to 89, right here, 89 over the NS, or just say is sigma F divided by, okay, 521. So we got it. This one, if you remember the formula, we just finished previous example. If we find only 4 or fewer year here, you can see we find only exact in this interval, correct? And separate them. This is a P of question A. This one's a P of 4 or fewer. And this is a P of 9 or fewer years. So they don't have common years, correct? It's of 0 to 4 and this one 5 to 9. So if you use the formula, the formula of the what they call the formula of the mutually exclusive, which is they have no common, that's become mutually exclusive formula, correct? So we're gonna have P union. From here we're gonna have this one, this another color, P. You can have P like a formula, right? PA union B equal to PA plus PB. Okay, and then for mutual exclusive, because this one have no common outcome or common element. So this one gonna be 0. You remember the formula? This one gonna be PA. This one have to be intercept, right? Intercept A. But this one no common outcomes. So this one equal to 0. So after this one, you just repeat. This PA mean the pink one here. Okay, so I like the color. So PA, that means P of the probability of 4 or fewer. So you refill it here, become 157 divided by 521 plus PB. PB mean this one, right? The question B here. So you're gonna have 89 over 521. Then you sum it up, and this one, because no intercept point, no intercept outcomes, so this one becomes 0. So you sum it up, and that's the answer. Okay, so we have what, 157 plus 89, so become 246 over 521. Okay, so divided by 521, if you're gonna count as a decimal point, gonna be approximate 0.472, I think, round up. Okay, so 0.4722. Okay, so we're gonna have 246 one more time divided by 521. Yeah, 0.4722. 0.4722. That's a property of for this question. Actually, you see this one similar to we learned in the statistic. If like a question A and B here, if we combine, right, say find the property which is less than 9. Remember, if find property is less than 9. For we don't need to combine, right? If say find the property of less than 9, so that means form these two interval, correct? That means these two interval. I use book this two interval. If find less than 9, right? Remember, find less than, greater than, between, something like that. And then less than 9, you just add this one up. Okay, you just add this one. If we use we don't separate by using in this formula. Know what I mean? If we did not separate by using this formula, right? So we can just say equation say find less than 9, right? Less than 9 years of the service. So we just get this one because less than, just go less than, correct? So less than 9. So you just get these two, add it up and divide it by total, do the same way. If they add percentage, you just time 100% and like the final answer have to have the percentage sign. Remember that one in statistics we learn. In this, like this case, I can ask you many questions. Can ask you like a mean, median, mode, right? Find the approximate of median and the mode, and find the exactly value of the median and the mode also to the formula I used to give to you, and then we can get the one, and can use for how to say, construct the box and visco pot, right? Find Q1, Q3, upper, lower quartile, upper quartile, or something like that. Okay, or you can find, if you find mean, median, mode, mean, you have to find midpoint first. Remember, by sum 0 plus 4 divided by 2, get the midpoint. That means the value of x first, something. So you see this, they're all related. So when you learn statistics, they're related to probability, and also probability related to statistics. And then one question like a table like this can ask you many questions. Okay, so I hope you recall what we just learned and we just finished for last few weeks. So I will leave it in at right here now, and this another the example of mutually exclusive events. Okay, so and again you can go back to your handout. If you still have it, if anyone doesn't have, you can line me, email you, and maybe I can scan and send you one more time. But I think most of you have, right? So you take it out for your handout. You can try the same exercise, okay? You can try the same exercise. Go to the exercise 8.7, right? 8.7 probability. Okay. On page 659. And then you can do question 47 to 49, maybe 3 questions, but to question 47, 48 is similar. They have to keep the table, but 49 doesn't have table. But see, I think for sure 48, 47 to 48, you can try. It's a similar idea to this example. Okay, I think that's all for today. Okay, for this mutually exclusive events and to example, we finish. And you can try the example. If you need help, just line me in the live group or individual. Okay. Okay. So I think that's all. Bye bye. See you next class. Bye.